Hi, welcome to the video on the final model problem for two-step mole conversion. So in this problem, problem 5, a 0.458 molar solution of NaCl contains 4.36 times 10 to the 25 NaCl molecules. What is the volume of solution in milliliters? So this is similar to problem number 3, where we're given sort of a bunch of information. We're given molarity, which means we're over here. We're given number of molecules, which means we're over here. We're asked to find the volume. So which exactly, are we starting here, are we starting the concentration, or are we starting with the number of molecules? The best way to do that when you're in a situation where you can't figure out based on what you're given, the number values you're given, what's your actual given and what you're trying to find, is by focusing on the find. We are asked what is the volume of the solution. Volume of solution, that means that what we're trying to find is this. So we're going to end here, okay? And as we're ending here, we will use this molarity information, but what we're actually starting with is this information here, number of molecules, okay? So our plan here is to go from number of molecules to moles, and from moles to the concentration. So that's, sorry, to volume, not concentration. So that's sort of our setup here. All right. Now that we have that, I'm going to again always show you using the equations first, and then I'll show you what the dimensional analysis setup looks like. Okay, so if we're going from number of molecules to moles, I'm going to use the 1 mole is equal to 6.02 times 10 to the 23. And when I solve that, there's many ways to solve it. Because as you can see here, this is not really an equation. Okay, this is, this is not an equation with an unknown, right? There's no unknown to plug in. So in this case, you can either use this as a proportion, or you can set it up using dimensional analysis to convert from your molecules to moles. And that's what I did here. And I've done that in the last 2 videos, so I'm not going to spend a lot of time doing that, but it's your given over 1, multiply it by the conversion factor, and since I'm converting from molecules to moles, molecules is 6.02 times 10 to the 23 molecules goes in the bottom, and the 1 mole goes on top. If I was converting from moles to molecules, then this would be flipped, okay? So if I was starting off with moles, and I'm trying to get to the number of molecules, then my 1 mole would be on the bottom, and molecules would be on top. But that's how the setup is. And then of course I go ahead and do my math. I plug this into my calculator. Again, I've showed you that 2 times in the previous video, so I'm not going to spend time showing you that here, but this is the math. I divide those out and I get 72.4 moles. So all I've done so far, go from molecules to moles by plugging my information in into a dimensional analysis setup. Okay, not quite an equation, but that's what we use when we're going from moles to number of molecules and vice versa. Now the next thing is I want to go to volume of solution. So for that, I'm going to use this equation here, of course. So I've got at my moles now. I'm going to use moles. Molarity is equal to moles over liters of solution. So my molarity, they tell me, is 0.458 molar. So I'm going to take that number and I am going to plug that in here. My moles I have already solved for, so that's going to go here. So why don't you take a moment to sort of plug those values into that equation and solve for your volume in liters. So what I'm going to do now that I have that plugged in, we have a fraction next to an equal sign. So remember, that means I'm going to use cross multiplication. I take that whole number, I put it over 1 to make it a fraction. And now I'm going to cross multiply. So on one side, I'm going to have 0.458 times liters. And on the other side, I'm going to have 1 times 72.4, which is just 72.4. Okay, so I got to isolate my unknown now. And I'll do that by dividing both sides by 0.458. And I get my liters is equal to 158 liters. Now, is that my final answer? No, that's not the final answer. And let me tell you why. Because they want the volume in milliliters. So I need to convert that, my liters to milliliters. And we do that simply by multiplying by 1,000. So if you have 158 liters, you times it by 1,000, it gives you 158,000 milliliters. And so this now is my final answer. All right, last one, dimensional analysis. If you're setting this up using dimensional analysis, it's always the same. Just remind you of the setup. Given over 1, you're going to multiply it by 2 conversion factors. In the first conversion factor, 1 mole is going to be on top, and then whatever your given units will be on the bottom. The second conversion factor, your 1 mole will be on the bottom, since you're trying to cancel those out now, and then the units of your find will be on top. And so that's what we have here. We have our number of molecules on the over 1, which is our given, times 1 mole over Avogadro's number. And then now the last thing is for our molarity. Remember, molarity is a tricky one. So we don't need to use dimensional analysis for molarity, because for molarity, when you're doing the sort of the flipped version of that, you have to consider that the molar has the units of liters, moles per liter. So the mole part of your molarity, the 0.458 moles of it will be on the bottom, and then the 1 liter will be on top. Okay, and so this is sort of what this looks like, because when you see 0.458 molar, that's saying 0.458 moles of solute over 1 liter of solution. And so we've got our moles in the bottom and our liters on top. And then the last part here, I just converted it from liters to milliliters by multiplying it by 1,000. So I added that as a 1 step. So we can see our units canceling out, and then that gives us the volume. Once again, when it comes to dimensional analysis, you really want to only focus on using that for mass to moles, or and vice versa, moles to number of atoms or molecules and vice versa, and moles and of volume of a gas at STP in moles. Okay, so that's when you can use dimensional analysis quite easily. You could also use it for molarity like I just showed you, but you don't have to. And you cannot use dimensional analysis for if you're using having to use the PV equals nRT equation. Okay, so I hope you found all of this helpful. You are going to do the first 5 practice problems at least on your own, and let me know if you have any questions. All right, folks, have a quality day.